Windows using too much RAM, how to diagnose resource hog. I have 16 GB of system RAM. On startup with no applications open except the taskmanager Windows is using about 3 GB of RAM. I looked in the processes tab, but nothing seems to be out of the ordinary. How can I find out why my Windows is using so much RAM? All processes from all users. Reading from the Pullman, it seems that my wireless Broadcom driver is using about 0.4 GB of RAM. Even if I remove it, would still be using 2.6 GB on startup, which is still too much. After reinstalling the wireless driver associated with the memory leak, I have a new screenshot and would like to confirm that it was indeed a memory leak.
You have a memory leak caused by a driver. Look at the high value of non-page kernel memory. In your case, this is over 3.7 GB. You can use Pullman to see which driver is causing the high usage. Install the Windows WDK. Run Pullman, sorted via P after pull type so that non-page is on top, and via B after bytes to see the tag which uses most memory. Run Pullman by going to the folder where WDK is installed. Go to Tools, or C:\program files, x86 Windows kits /10 tools x64, and click pullman.exe. Now look which pull tag uses most memory as shown here. Now open a CMD prompt and run the find command. To do this, open CMD prompt and type cdc:/windows/system32 drivers, without quotes. Then type find/s_, where underscore is the tag, leftmost name in Pullman. Do this to see which driver uses this tag. Now, go to the drivers folder. C:\windows/system32 drivers, and right-click the driver in question, index.sys in the above image example. Click Properties, go to the Details tab to find the product name. Look for an update for that product. If the pull tag only shows Windows drivers or is listed in the pulltag.txt, C:\program files, x86 Windows kits /8.1 debuggers x64 triage pulltag.txt. You have used Sperf to trace what causes the usage. Install the WPT from the Windows SDK. Open a cmd.exe as admin and run this. Sperf on proc_thread plus loader plus pull stack walk pull alloc plus pull free session plus pull free session buffer size 2048 max file 1024 file mode circular and amp and amp timeout -1 and amp and amp sperf dc:\pool.edl. Capture 3060s of the GRO. Open the edl with wpa.exe. Add the pull graphs to the analysis pane. Put the pull tag column at first place and add the stack column. Now load the symbols inside wpa.exe and expand the stack of the tag that you saw in Pullman. Now find other third-party drivers which you can see in the stack. Here the thread tag, thread, is used by ifco.exe from gdata. Look for driver/program updates to fix it.
Well, first thing, before I go into a more detailed answer. In your first screenshot, your non-paged pool, a type of kernel memory usage, is at 1.3 GB. That seems unusually high to me, especially for only 30 minutes after boot. I guess I could see NP pool getting that high after an extended amount of use or with a program that was leaking like a sieve. To contrast, my NP pool is usually between 100 and 200 megabytes, and my paged pool might be as high as 400 or 500, and that is after having my system running without a reboot for weeks. You can enable a few additional columns in Task Manager by right-clicking the column headers and choosing Select Columns. You should add Working Set, Private, Working Set, Shared, Commit, and NP Pool. I'd scan through all your processes from all users and see if any of them have an NP pool more than about 256 kilobits. If you see any, especially any that are considerably higher, that might be the source of the problem, or at least part of it. Your total working set, the amount of physical memory in use by a process, is the combination of the private and shared working sets, WS. Private is usually bigger for most processes, however there may be some that use a larger amount of shared WS. The two should normally sum to the total WS. Commit is the amount of your working set that has been committed to the backing store, in most cases, the Windows page file. Backgrounded applications will frequently have a greater commit than WS, indicating that much of their paged pool has been swapped out of memory and into your paging file, which is pretty normal for desktop apps that have been minimized and not used for a while. The non-paged pool is memory that cannot, and never will, be swapped out of physical memory. That is effectively your permanent minimum physical memory usage. NP pool memory often contains program code and critical sections that must be in physical memory to behave correctly or securely, special heaps, etc. Out of 60 processes, if all of them have 256 kilobits of NP pool memory, then your absolute minimum physical memory usage would be around 15,360 kilobits. In most cases, one or two apps may have a 256 kilobits NP pool, while most have less, often considerably less, or none. It is highly unlikely the system would ever page out the entirety of all processes' working set, so don't ever expect memory usage to get that low. Finally, the point of having more memory is to avoid having to page data to and from extended memory space, swap, page file, on a physical disk. Paging is a process that involves moving blocks of allocated physical memory around, pushing some to disk, and bringing others into physical memory from disk. Paging is, to keep it simple, highly undesirable. It isn't bad per se, but it can be a real drag on performance when it occurs too frequently. The ultimate point of increasing the total physical RAM in a system is to allow more processes to keep more of their commit in physical memory, larger working set. Consuming memory is not a problem, and when more executing processes use more memory, total system performance and active process performance will usually be higher, as physical disk activity related to memory accesses, page faults, specifically, will be lower. Windows manages memory for you, and automatically pages data in and out of memory to and from the page, swap, file for you. If you run a process that needs 9 GB of memory and your system is already using 4 GB, out of 12 GB, then the system will automatically figure out which processes do not need immediate access to their entire working set, and it will page some or all of their paged pool out to swap in order to free up that extra 1 GB. If your large process eventually needs more memory, Windows will further reduce the working set of other processes until it has enough free space to allocate the newly requested block. Your large process could eventually consume all available memory except NP pool and perhaps some additional minimal overhead for periodically executing processes that aren't allowing Windows to free up more of their working set, i.e. they have pending page faults that Windows would otherwise swap out of physical memory, but because they are being requested, they cannot be moved. If a process needs more memory than it is allowed to access, 32-bit processes can usually access 2 GB, and some a little less than 4 GB with enhanced techniques, while 64-bit processes can usually access around 48 GB of memory each. Then Windows will sometimes try to virtualize its memory with swap space. If a 32-bit app wants to use its maximum allowed 2 GB of space, but only 1.2 GB are available, Windows will reserve the full 2 GB in the page file, and move the process's own data in and out of the page file as needed in order to support the app's memory usage. Total memory usage in this case may appear to be greater than the available physical memory, when going by total commit. Total commit will usually max out at the grand total page file size, which when managed by the system, is usually 2-3x the physical memory amount. In your case, total commit would be around 24 GB, or 2x your 12 GB physical memory, and this is indicated in your first screenshot, where it states, commit, GB, 323. One final point. You said in your answer that you had 16 GB of RAM, whereas taskmanager only sees 12 GB of RAM. One of two things here. Either your system really does only have 12 GB of RAM, or one of your sticks is not registering properly. If a stick of RAM, I am assuming 4x4 GB sticks, it may be bad, may not be seated entirely properly in your motherboard, or your motherboard may have a memory detection issue. To check if it is the latter, you should first update your motherboard BIOS to the latest version. I had a similar problem. My 6 triple-channel DDR3 sticks of RAM, 6x2 GB, were all good based on individually testing each one, but my motherboard randomly decided not to count 1 or 2 of them every so often leaving me with only 8 GB of RAM. A BIOS update fixed the problem, and I have reliable access to all 12 GB of my memory now.
How can I find out why my Windows is using so much RAM? It's using so much RAM because it is designed to do so. There is absolutely no cost associated with using RAM. In fact, used RAM is better than free RAM because the operating system doesn't have to do anything to use it. Using free RAM requires making it used, which takes effort. If you're thinking I want my RAM free now so I can use it later, forget it. RAM does not have to be free now to use later. You can use it now and use it later. There is no trade-off here, there is absolutely no downside to using RAM. RAM is kept to use and directly switched from one use to another without having to go through the effort of making it free just to have to make it used again. Modern operating systems leave RAM free only when they have no other choice.
A reason not mentioned above is Hyper-V. I was able to identify it with the excellent utility RAM app. The screenshot is from after. Before the driver locked memory was over 6 GB, more than 80% of the RAM in this particular machine. I had to go into Hyper-V Manager and disable dynamic memory. Curiously, even after re-enabling it, the driver locked memory stayed low. I can only presume prior instances increased it and that Hyper-V does not automatically reduce its allocated memory.